Hi, everybody. My name is Ave Heath, and today I'll be presenting on the article Females Have a Different Metabolic Response to Critical Illness Measured by Comprehensive Amino Acid Flux Analysis. This study investigated whether biological sex influences whole body amino acid metabolism during critical illness using a comprehensive stable isotope tracer analysis. But to understand a little bit more about this, I'll provide some background on the metabolic response to critical illness. So, previous studies have reported differences in clinical outcomes between male and females in the ICU. The metabolic basis for those differences, however, is unclear. Most investigations have relied on plasma amino acid concentrations, which measure how much of an amino acid is present, but can't determine how quickly it is being produced or utilized. So, to address this, the authors investigated whether whole body amino acid metabolism differs between the critically ill sexes using the stable isotope tracer analysis. This study included 51 critically ill ICU patients and 49 healthy controls, with ICU patients classified by illness severity using SOFA scores. Researchers administered 18 stable isotope tracers and measured whole body amino acid production using the LC-MS-MS and compartmental flux analysis. Unlike plasma concentration measurements, however, this approach quantified amino acid kinetics, which allowed one of the first comprehensive comparisons of metabolic responses between critically ill males and females. So, critical illness induces a hypercatabolic state in which the skeletal muscle protein is rapidly breaking down to meet the body's increased metabolic demands. The amino acids released from muscle are redistributed to tissues such as the liver and immune system, where they support acute phase protein synthesis, immune function, gluconeogenesis, and energy production. But because amino acid metabolism drives so many of these adaptive responses, understanding how these pathways change during critical illness was essential to this study. So, like I said, rather than relying on plasma amino acid concentrations, they measured the whole body amino acid flux using the isotope tracers. Plasma amino acid concentrations measure the amount of amino acid in circulation at a single point in time, whereas flux analysis measures the rate that they're produced and utilized through the body, as said before. This approach allowed the researchers to identify changes in metabolic activity and determine whether specific pathways responded differently in critically ill females or males. So rather than measuring every amino acid independently, the investigators selected pathways that represented key metabolic processes during critical illness, including the glutamine to glutamate metabolism, citrulline to arginine metabolism, the phenylalanine to tyrosine conversion, and of course, whole body protein breakdown. Together, all of these markers identified which metabolic processes differed between the sexes. So, major findings compared with healthy controls, critically ill patients had significantly greater whole body amino acid production, which confirmed the expected hypercatabolic response. But more importantly, the females demonstrated greater metabolic responses than males across several pathways. Even after correcting for protein breakdown, glutamine and glutamate production remained higher in females, suggesting pathway-specific regulation rather than a simply greater muscle breakdown. Females with more severe illnesses also showed reduced amino acid production, indicating that metabolic adaptation may decline as illnesses progress. So this paper expanded my understanding in three different ways. First, amino acid flux provides more of a complete picture of metabolism than plasma concentrations alone. Second, I learned that biological sex independently influences amino acid metabolism during critical illness, suggesting that nutrition needs may differ between males and females. And finally, I learned that metabolic adaptation changes with illness severity, emphasizing the need to continually reassess nutrition support. So, although this study does not support changing current ICU nutrition guidelines, it provides important clinical insights. Nutrition assessment should be an ongoing process with protein and energy individualized as metabolic demands change. During recovery, counseling should emphasize adequate protein intake, lifestyle changes to produce and or preserve and rebuild lean muscle mass. Um, yes, sex-specific recommendations need more evidence before they really can be made, but these findings do support future personalized nutrition strategies. In conclusion, whole body amino acid flux provides a more complete understanding of metabolic adaptation than plasma amino acid concentrations alone. The study also demonstrated important sex differences in the amino acid metabolism during critical illness, particularly within glutamine and glutamate pathways. Before clinical practice is changed, there does need to be additional research, and these findings do, however, provide an important foundation for future precision in nutrition research and nutrition response in critically ill patients. Here is my reference article, and thank you.